Hello learners, welcome to the world of mathematics. In the last class, we have covered how the sets and the intervals behave, and we have understood the basics of those. And in this session, we are going to understand what are inequalities and one of the very fine method, which is the wavy curve method to solve those inequalities. Let us start. So we'll start from expressions, equations, and inequalities. So expressions, these are the mathematical statements with at least one operation. There is one operation which is involved into it, either addition, subtraction, multiplication, division, etc. These are expressions. So basically 3x square plus 5x plus 6. So plus is the operation here. It could be minus also. It could be multiplication. 3 and x square are multiplied to each other. So these are one or more operations which are there involved in it, and this is called an expression. Now, if that expression has a sign which has an operator of equal to sign, then it's called an equation. So it can be this expression equal to 0 or one expression equal to another expression. Similarly, when this expression is separated not by an equal to sign but a greater than, less than, greater than equal to, or less than equal to sign, then it is called an inequality. So these are the examples of inequality. So this is greater than equal to 0 and one expression less than another expression. These are some of the inequalities which we can see. Now, we in our earlier classes we have seen how to solve some expressions, etc., how to factorize all those, how to solve the equations, the equal to sign equations, etc., in general, right? Now we will be learning about how to deal with inequalities, and one of the finest way to do it is through wavy curve method. What is the wavy curve method? It is the general way of solving the inequalities you want to solve, right? So this is the best way, one of the best way to deal with this. Be very careful here. Understand each and every step which I am going to tell you in the next slide, and understand it and try to apply it in the questions coming forth. Let's start. So how to solve these inequalities using wavy curve method? First of all, there is an expression given to you. The right hand side of the expression should be equal to 0. It must be 0. If it is not 0, make it 0. So if the right hand side has some other expression, actually you can bring it on the left hand side and express it as equal to 0 or less than equal to 0 or greater than equal to 0 ultimately. So right hand side has to be 0. Okay, if it is not there, then bring all the expressions on the LHS and make it 0. Now factorize the LHS. In the second step, factorize the LHS, and if the factors are appearing multiple times, express it in the terms of powers. So in this case, in this particular case, as you can see that x plus 3 has been repeating 2 times. So I have not written in the expanded form. I have written it as x plus 3 whole squared. It should be expressed in terms of powers. Cancel the common expressions in numerator and denominator, but we have to keep in mind that all the factors in denominator can never be included in the solution. So that is one of the key things which we need to take care of. Plot those factors on the number line. So in this case, I'm going to plot all the factors on the number line. So say I'll take 0, then this is 2, this is 5, then this is minus 3, and this is 15 by 2. So I'm just writing the factors of all the points in numerator and all the points in denominator separately. Okay, I have found out all the factors. X equal to 0 is one of them, x equal to 2, x equal to 5, x equal to minus 3, x equal to 15 by 2. So all of them I have plotted on the number line. Be very careful here that it should be in the relative positioning of these points should be correct. Okay, so the distance between them does not matter at all. but the relative position, so 2 should come after 0, those kind of things, etc., should be taken care of. Minus 3 should be on the left hand side of 0, those kind of things, etc., should be taken care of. Now, whatever are the factors in numerator, make it through a solid dot, the way I have done here. Okay, 0, 2 and 5 are the factors in numerator, so I have made it through solid dot, and the denominator factors are written in the open dots. Okay, so this taken care of. If the roots are repeated even number of times, I'll mention E just below it. So x is 0 is repeating odd number of times, only one number of times, so it's okay. This is also okay, this is also okay. X plus 3 is repeating 2 times, right? So x plus 3 is repeating 2 times, that means minus 3 is getting repeated 2 times, so I'll write E at the bottom. 15 minus 2x power 5, 5 is an odd number, so that is okay. So I'm not bothered about other points altogether. So whatever is repeating odd number of times, it's all okay. Whatever is repeating even number of times, I'll write E just below it. Okay, now I'll take a very very high value of x and try to estimate the sign of fx. So for a very high positive value of x, this will come out to be a positive number. I'm just going to find out whether it is going to be positive or negative. So positive, this will be positive, this will be positive. So numerator will be entirely positive. Okay. This will be positive and this, but this would be negative. 15 minus 2x, for x being a very very high value, say 100,000, 10,000, whatever high value you can think of, this expression is going to come out to be a negative number. So because of this, and this is odd powered, so this entire expression will become negative. So if this final thing for a very high value of x is coming out to be negative, I'll start from the bottom of the line. If it turns out to be positive, I'll start from the top of the line. If it is negative, I'm starting from the bottom of the line. So actually I'm starting from here and making a wave. So wherever is the point, I'll cross it, I'll cross it, I'll cross it, I'll cross it, I'll. Okay, so for even if the wave, we will make the wave, this is the wave, that is why it is called the wavy curve method. But for this point, this particular point minus 3, E is written there. So wherever it is repeating even number of times, I will reflect the wave. So this is reflecting. This is not crossing the line. This is going to reflect. And hence, the solution to this problem is going to be, so I have to take all the negative values. This negative, this is negative, this is negative, and this is negative. So for x belonging to minus infinity to minus 3 union minus 3 to 0 union 2 to 5 union 15 by 2 to infinity. For these values of x, this expression will come out to be less than or equal to 0. This expression will come out to be less than or equal to 0. Very carefully, what I have done is, I have included the points which are solid points. Okay, 2 is a solid point, I have included it. 5 is a solid point, I have included it. 15 by 2 is not a solid point, I have not included it. Similarly, minus 3 is not a solid point, I have not included it. Even though it is coming here also, very clearly, the expression is negative here also and here also. But at minus 3, it is not defined. So I have to exclude this minus 3, right? And wavy curve method takes care of this piece also. And that's why we can write the entire expression. So these are the values of x for which this expression will come out to be less than or equal to 0. Very quickly, going through these kind of questions also, I've taken up some questions automatically here. So let's see how to solve this. So 2x, there is some expression on the right hand side. I have to bring it on the left hand side. 2x square plus 5x plus 2 minus 1 by x plus 1 is less than or equal to 0. Okay. this will come out to be equal to 2x into x plus 1 minus 2x square plus 5x plus 2 whole divided by 2x square plus 5x plus 2 into x plus 1. I'll solve it. Okay, so this comes out to be 2x square plus 2x minus 2x square minus 5x minus 2. Okay, and 2x square plus 5x plus 2 can be expressed as 2x square plus 4x plus x plus 2. Okay, 2x common, x plus 2 plus 1, x plus 2. So this can be expressed as x plus 2 into 2x plus 1. So I have to factorize all the denominator piece also. That is coming out to be 2x plus 1 into x plus 2, and x plus 1 is copied. Okay, 2x square into x square fortunately gets cancelled. This comes out to be equal to minus 3x minus 2 whole divided by 2x plus 1 into x plus 2 into x plus 1 is less than or equal to 0. Now what we will do is simply we will I'm just changing the ink. I'll make a number line. Okay, for this I can write this as minus common 3x plus 2. So one of the factors is minus 2 by 3, minus 2 by 3. Relative positions should be fine, and this is a solid point I'm actually making. For minus 1 by 2, what is the relative position? Minus 1 by 2 is actually just here. So minus 1 by 2 open point. Then x equal to minus 2 should be here, and minus 1 should be here. And all of these are open points. Now for a very high value of x, this is negative, this is positive, this is positive, this is positive. So entire thing is negative. So this is negative, and then nothing is repeating. So there is no reflection of wave. So it will be proper wave altogether. Right? And we have to take only the negative portion. So this is the negative portion, this is the negative portion, this is the negative portion. So x belongs to minus infinity to minus 2 union minus 1 to minus 2 by 3 union minus 1 by 2 to infinity. So if I take any value of x within this expression or this inequality will hold true. Okay, so this should be quickly taken care of. For such kind of cases, I'm quickly trying to do this question also. So quickly, x equal to 1, x equal to 2, x equal to 3, and 3 is repeating even number of times. So I'll write e at the bottom. X equal to 4, open interval 4. Okay, this is a closed interval, closed interval, closed interval. Okay, and x equal to 5, x equal to 4 is also repeating even number of times, so it's okay. And x equal to 5, and that is repeating odd number of times, so I'm not much bothered there. Now for a very high value of x, this is positive, this is positive, 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 everything is positive. So expressing here, then this, then this, then this, and this is fine. So wave will continue like this, and I have to take only the positive values. So x will belong to, and see here, there is no equal to sign here. So everything would be an open interval. For equal to sign, so what will happen is at x equal to 1, as soon as I put x equal to 1, this will become 0. I don't want it to be 0. So I will not include any of the points on the number line. Okay. So very clearly, very quickly, I can say that it is from minus infinity to 1, union 2 to 3, union 3 to 4, union 4 to 5, and that's it. Okay, now 3 was included, but I have keeping that thing also in the exclusion piece, because as soon as x equal to 3, this expression will become 0. But I am actually looking for something which is exactly greater than 0, not equal to 0. So that's why I have excluded all the points across the number line. Okay, so that is also one of the very key things which you need to take care of. The last one, 2 by x minus 3. So what people do is basically they put x, so they multiply throughout by x and they write it as 2 is less than 3x. No, this is wrong. Okay, why I'm saying this is wrong? Because you don't know whether x is positive or negative. If x is positive, yes, you can write it like this. But if x is negative, you cannot write it like this. We'll discuss this in the next class. But this is not admissible. So that's why please keep it as 2 by x minus 3 is less than 0. And then solve it in a regular way. 2 minus 3x divided by x is less than 0. Make a number line. This is 2 by 3. One of the factors is 2 by 3 and it's a hard point. And then 1 is x equal to 0 is an open point. Nothing is repeating. For a very high value of x, this is coming out to be negative. So negative, positive, negative. I have to take care of only the negative ones. So x will belong to minus infinity to 0 union, and this is not less than or equal to sign, so I have to keep everything open. 2 by 3 to infinity. Okay, so go through these examples again and again. Try to do more questions from different kind of books, etc. For inequalities. You'll get to understand this very well. Okay, to join our regular weekend batch, you can drop it here. Please feel free to like, comment, subscribe, share, and turn on the notification so that you can keep on getting these more of these videos. Thank you.